The following video is on 3D vectors. And the idea of a 3D vector is that, well, let's look at a 3D Cartesian grid. Now, a 3D Cartesian grid, unlike a normal Cartesian grid or an XY Cartesian grid, which is two-dimensional, this one is three-dimensional. So, think of this as like the corner of a classroom. When you come, if you're in the corner and you come towards us, that is along the x-axis. If you go to the right, that is our y-axis. And if you go up, that is our z-axis. So these are all positive values. If I go forward along the x-axis, this is positive 1, positive 2, positive 3, positive 4. If you go to the right, this is positive y, positive 1y, positive 2y, positive 3y, positive 4y. And if you go up, this would be positive 1z, positive 2z, positive 3z, and positive 4z. Now let's look at our first problem. The first problem says consider that we have this point t at 3, -1, 4, and it says draw a diagram to locate the position of t in three-dimensional space. So we have our grid. This is our x, y, z Cartesian grid. We're going 3 units to the right, 1, 2, 3. We're going 1 unit to the left, so that would be here, so that would be over here somewhere. And then, so we have this image like this. My x is sort of getting in the way. I think this is probably a bad demonstration so far. This is my x here. And then 4 units up, so 1, 2, 3, 4. So we end up having something. I did not do a very good job constructing this. So this is going to be behind the wall, and we have this point right here of t, which is 3 forward, 1 behind the wall, and then 4 up. It says here, how far is it from 0, O, or 0 is always going to be at our origin. What is the distance between 0 and t? So I'm going to use a different pen. I'm going to, looking at this, I want to know the distance here, and if I drew this as a vector, then we're really just trying to find the magnitude. Now, for this particular magnitude, for this length here, we can construct a right triangle. We can construct a right triangle like this, with our base being a diagonal and our height being, well, the height is 4, and the base of this right triangle is our diagonal here. We can calculate that using the Pythagorean theorem, which would be, this is 3 and 1, so we can calculate this base here by taking the square root of 1 squared plus 3 squared. And then our height, so this is our A, this is our A value here for the triangle that we're trying to figure out, squared, plus our B value, which is 4, plus 4 squared, and that should equal our magnitude squared. And if we want to find the magnitude, then we have to square root both sides. So that gives us the square root of this quantity of the square root of 1 squared plus 3 squared plus 4 squared. Well, the square root squared, they are inverses of each other. They undo each other, and we're left with then the square root of 1 squared plus 3 squared plus 4 squared equals the magnitude. Now, if you look at our triangle, actually, I suppose that, well, even though this is negative, the negative squared is still negative. So my point is that if we want to find the distance of this particular, the distance from the origin of this point, we'd really just take the square root of 3 squared plus -1 squared plus 4 squared. So 3 squared, that's 9, plus -1 squared, that's 1, plus 4 squared, which is 16. And we take the square root of all this. 9 plus 1 is 10, plus 16, that's going to give us 26. We have the square root of 26. All right, so that's our distance. Now let's look at number 2. So it says illustrate P and find its distance from the origin. Well, if we wanted to illustrate this, we're going to draw our Cartesian grid. This 0 represents our x value, that's towards us. The 0 is our y value, which is to the right. So 0 spaces forward, 0 spaces to the right, and 3 units down. So that would be 1, 2, 3. We're looking at this particular point below the floor. This would be P. Here with our Cartesian grid, again, this is our x, our y, and our z. 0 spaces in the x direction, 1 space behind the wall in the y direction, and 2 units up. So 1, 2, so behind the wall, 1 space, and then we're going up 2 units. So we're looking at a point right here, behind the wall, which is really on a 2-dimensional surface because we didn't move any spaces forward. That's our P value. All right, let's look at the next one. Here's our Cartesian grid, 3 units to the right, or 3 units forward, 1, 2, 3. 1 unit to the right, 1 unit to the right, so that would be, we could construct a little rectangle here. And then 4 units up, so 1, 2, 3, 4. So we're looking at something that's going to look like this. So we're seeing this point right here of P. That is P. This is P. All right, one more. So here's our x, our y, our z axes. 1 unit behind the wall in this direction, -1. We're 2 units behind the wall in this direction, 1, 2. It's already looking like it's going to be difficult. And then 3 units up, 1, 2, 3. So some point right here, that is our P point right there, behind the wall in both directions. All right, let's look at the next one. It says, given we have 2 points, we have point A, which is at -3, 1, 2, and we have point B at 1, 0, -1. And I want to find vector AB, and from our previous video, we should have learned that it's just head minus tail. So we're going to take the head of the vector, which is B, 1, 0, -1. That's a -1. And I'm going to subtract that from A, which is, I'm going to subtract that from A, which is -3, 1, 2. So negative, negative makes a positive. I have 4, -1, -3. That becomes my vector AB. Well, what's vector BA? Well, we're just going in the opposite direction. So for BA, that's just going to be negative of this vector. So that becomes -4, 1, and 3. So there, this is our other vector going in the opposite direction. Now I have to find the magnitude of this vector, the magnitude of a vector. So this is going to be, we're just using the Pythagorean theorem of 4 squared plus -1 squared plus -3 squared, all under a square root. 4 squared is 16. -1 squared is -1 times -1, which is 1. And -3 squared is -3 times -3, which is 9. So I have 16. Let's do 1 plus 9, that's 10, plus 16, that's going to give us 26. So I have the square root of 26 as the length or the magnitude of this vector. Well, what's the magnitude of my other vector going in the opposite direction? Well, the direction changed, but not the magnitude. So this magnitude of this other vector should also be the square root of 26. We should probably give it units, so I'll just write the square root of 26 units. All right, moving on. I'm not going to do all of these. I think that most of these are pretty basic. So it says here, find the position vector if not otherwise indicated. This O means that we're at the origin. So I have this point at -1, 2, 5. What is my vector? Well, my vector is going to be -1, 2, 5. And then the length of this vector, well, we just use the Pythagorean theorem again. So -1 squared plus 2 squared plus 5 squared, and then we just calculate it all out. It's pretty basic. All right, let's just do another one. So it says find the position vector of A to B. So we're just going to do head minus tail. So 2, 0, 3, and we're going to subtract it from the tail, which is -1, 2, 5. That gives us 2 minus negative, that's a positive 1. That's 3. 0 minus 2 is -2, and 3 minus 5 is -2. And if I want to find the length of it, it's the same concept. Just make sure that when we have negatives that we use parentheses of 3 squared plus -2 squared plus -2 in parentheses squared. Because let's recall that -2 squared is not the same thing as -2 in parentheses squared. This -2 squared without parentheses is -2 times 2, which is -4. And -2 in parentheses is -2 times -2, which is a positive 4. -4 never equaled 4. So these do not equal each other. And the Pythagorean theorem says all of A squared plus all of B squared equals all of C squared. So we are going to square whatever A is, whether it's positive or negative, it's all going to be squared. All right, I'm going to just skip these. I think a lot of these are just common sense kind of things. We've done a lot of these already, so I don't really feel that I'm giving you any more guidance. So let's get down to 7. It says, find the shortest distance. Find the shortest distance to this point, or from this point of Q, 3, 1, -2, to the y-axis. Well, this is some point that's hovering out in space. In fact, let's draw this out. So we have our Cartesian grid, 3 units forward, 1, 2, 3, 1 unit to the right. So we're looking at 1 unit to the right, so we're here, and then 2 units down. So 1, 2, so 2 units down. So we're looking at a point that's going to be about here. So I want to find the distance, the shortest distance to the y-axis. This is my y-axis here. Well, the shortest distance to the y-axis is going to be, this line here. That line here. Well, how do we calculate that line? Well, this length here, that is -2, or 2. So we'll reconstruct this triangle. That's 2. This distance here is 3. And so we're trying to find this, I'll just call it the magnitude, but yeah, we're not talking about vectors, but the shortest distance to this line here is just going to be the square root of 2 squared plus 3 squared. You can figure that out. What about the origin, the distance to the origin? Well, if we're looking at the distance to the origin, then that's going to be the square root of 3 squared plus 1 squared plus -2 squared. We're just looking at, if this was a vector of 3, 1, -2, we're looking at this line from here to the origin, and so that's just the magnitude of that vector. So there you go. And then the last one says the shortest distance from the y-o-z plane. So we have the y, we have the o, this is point here, and the z plane. So we're looking at this plane here. So if I want to know then what the shortest distance to that plane is, well, recall that that plane continues all the way down as well. So we're really just looking at this distance here to that y-o-z plane. The y-o-z does not end here, it continues in all directions forever. So we're looking at this distance here. So that shortest distance is going to be this line here. That would be 3. So it's just going to be 3 units. All right, moving on. Number 8 says, show that this point here, P, 0, 4, 4, and Q, which is 2, 6, 5, and R, which is 1, 4, 3, are vertices of an isosceles triangle. Well, what is an isosceles triangle? An isosceles triangle is a triangle that has 2 sides of the same length and one side that is a different length. Well, if the other length was the same length, then it would be an equilateral triangle. it would be an equilateral triangle. And if all of the lengths were different, then that would be a scalene triangle. So I want an isosceles triangle where two of the lengths are the same and one is not. Well, how do I do that? Find the magnitude from P to Q. Find the magnitude from P to R. Find the magnitude from Q to R. And then if this is an isosceles triangle, then that would mean that two of these magnitudes would be equal and the third one would not be. So I don't really feel, we know how to do magnitude already, just the square root of, well, first we have to find the distance, right? We have to find the vector of PQ, so that would be head minus tail, and then we find the magnitude of that new vector for each one of those. I think that's a pretty good explanation for now on that. Let's look at number 9. It says use side lengths to classify the triangle of ABC. So I'll just do one of these and then give the coordinates. Well, the first thing that I want to do, if I want to classify, I think that because this is a triangle, I'm guessing that I'm trying to prove that this is either equilateral or isosceles or scalene. So first I'm going to find my vectors. I'm going to find A to B, which is going to be head minus tail, so 2, 8, 1, and I'm going to subtract these values of 0, 0, 3. That gives me 2, 8, and then 9 minus B. I'm sorry, I did 2, 1. Oh, this is 1 minus 3. This is 1 minus 3, which would be negative 2. We want to find A to C, which is going to be C, which is our head minus tail, negative 9, 6, 18. And I want to subtract that from my tail, which is 0, 0, and 3. That's going to give me negative 9, 6, 18 minus 3 is going to give us 15. And then we also need to find B to C. So that's going to be negative 9, 6, 18. And then we subtract our B value of 2, negative 8, and negative 1 to give us negative 9 minus 2, which gives us negative 11, and 6 minus 8, that gives us negative 2, and then 18 minus 1, which gives us 17. And then we have to find the lengths. We have to find the lengths using the square root of 2 squared plus 8 squared, and then in parentheses, negative 2 squared, and add all those together. And again, we're looking at if they are all going to be equal lengths, then it's an equilateral triangle. The classification would be equilateral. If I have two lengths that are the same, it's going to be isosceles, and if all of the lengths are different, it'll be scalene. Right, continuing, number 10, it says the vertices of the triangle ABC are given here. It says use the distance to show that the triangle is a right triangle. I want to show that the distances are a right triangle. Okay, so let's first find these triangles. We have triangle AB, we have vector AB, which would be 6, 12, 9. We're going to subtract the other point, head minus tail. That would give us 5, 6, and negative 2. That gives us 6 minus 5, that's 1. 12 minus 6 is 6. And 9 minus negative 2 is 11. And then we're going to do the same thing with A to C. That would be 2, 4, 2. We're going to subtract our tail, which is A. That would be 5, 6, negative 2. That's going to give us a new vector of 2 minus 5, which is negative 3, and 4 minus 6, which is negative 2. And then 2 minus negative 2 is going to give us 4. And then we also have to find our other vector from B to C. That would be head minus tail, 2, 4, 2. Subtract the tail, which is 6, 12, 9, to give us negative 4, negative 8, and negative 7. So we're going to find the magnitude of each one of those. The magnitude of each one of these, so we're going to take the square root of 1 squared plus 6 squared plus 11 squared. That gives us the square root of 1 squared, which is 1. 6 squared is 36, and 11 squared is 121. So we get some number, 121, 121, plus 36, plus 1, 6, 7, 8, 3, 4, 5. I'm getting 158. And then our other one, we have the square root of negative 3 squared plus negative 2 squared plus 4 squared. Getting sloppy. If you're sloppy, if I'm sloppy, I'll make a mistake, and then I won't be able to go back and fix it. Well, it'll just take time, and I don't want to spend the time in this video to do that. So I'm hoping I'm not too sloppy. Negative 3 squared is going to give me negative 3. All of negative 3 squared is going to give me 9. And negative 2 squared is going to give me 4. And 4 squared is going to give me 16. So 9 plus 16 is going to give me 25. 25 plus 4 is going to give me 29. So I have the square root of 29. And then the last one, we have the square root of negative 4 squared plus negative 8 squared plus negative 7 squared, all under the square root. Negative 4 squared is 16. Negative 8 squared is 64. And what was that? 7. Negative 7 squared is 49, so plus 49. So when we add up all these, that's going to give me, well, let's just add them all up. So we have 64 plus the 49 plus the 16. 9 plus 4 is going to give us 13. What was that, a 6? 13. Plus the 6 is 19. And then we add up these 6. 6 plus 4 is 10, plus 1 is 11, plus 1 is 12, so I have 129, so I have the square root of 129. Now, if this is a right triangle, and these are all my lengths of this right triangle, then shouldn't it be true that a short side squared plus a short side squared should equal the longest side squared? So the question is this true? Then, I'm running out of room, so I'll just use another piece of paper. The square root of 29 squared plus the square root of 129 squared, does that equal the square root of 158 squared? Well, square root squared, those are inverses, leaving me with 29. Square root squared again leaves me with 129. And then does that equal 158? And it does. I get 158 equals 158. So this is evidence, because a squared plus b squared equals c squared. This is evidence that this triangle is a right triangle. I don't have a lot more time left, so I don't know how much further I'm going to go, but we can look at 11. It says a sphere. We have a sphere. We did an example like this already with 2 dimensions in the previous video. Just remember, we have a circle. The center of the circle is at C of negative 1, 2, 4. And we have says we have a diameter of A to B, and A is at negative 2, 1, 3, and C is at negative 1, 2, 4, and I want to find the coordinates of B. How do you find the coordinates of B? Well, find this vector. Find this vector, head minus tail, and add it to this other point. And that will give us this other coordinates. So I think that's pretty straightforward. If we take this vector from A to C, and we find this vector in between, which is head minus tail, so 1, 2, 4, and we subtract it from negative 2, 1, 3, to get 3, 1, 1. Then we take this new vector and we add it to this point, and that should be 3 plus 1 is 4, and 1 plus 2 is 3, and 1 plus 4 is 5. So that should be our coordinates here of 4, 3, 5. All right, I think that this might be, I mean, these are mostly fun problems, and I would like to continue, but I just don't want the video to go too long. So I think this is going to have to be the last one. It says, find these points of A, B, and C. Well, if this is A minus 4 should equal 1, right? This is my x coordinates, or the x component. So we have A minus 4 equals 1. We just solve for A, just use proper algebra to get that A equals 5. So A equals 5. We do the same thing with B. So I have B minus 3 equals 3. Proper algebra, I'm going to add 3 to both sides. I get B equals 6. B equals 6. And then c would be c plus 2 equals negative 4. I'm going to subtract 2 from both sides to get c equals negative 6. And then the last one, well, this isn't any different. We're just going to use algebra. A minus 5 equals 3 minus a. Combine our like terms. We're going to add a to both sides. That gives us 2a minus 5 equals 3. We're going to add 5 to both sides. That's going to give us 2a equals 5 plus 3 is 8. Divide by 2. That gives us a equals 4. And we do the same thing with all the rest of them. I hope this was helpful, and have a wonderful night.